so we're dealing with circles today. Okay? And to define using a picture is for sure a great route to go with these. A circle, obviously most of you know what a circle is. I'm assuming you've seen them. Just so you know, we name a circle by its center point. So if this was, say, center point C, we would call this circle C. And so sometimes you see a little deal like that, read as circle C. Okay, kind of tough to see, but all right. So that might be how you actually see it labeled on a paper. Okay, you go by that center point. All right. If I'm defining these things, the radius of a circle, is radius all the way or halfway? Halfway. Radius is halfway. It's a shorter word, so it's a shorter measure. That's what I like to think. Okay, radius versus diameter. Okay, the other way to think of it, if this is your radius, okay, that's your radius, or rad. I just put rad, but that's your radius. Another way to think of it, if you have a circle and you have a center point, if you draw a line straight down through the center point, check it out. What letter do you have? That's so cool. Diameter. Yeah. Okay, some of you don't think it's as cool as I do, but that's pretty cool. All right. So that's your diameter. Okay, cuts a circle in half. It makes a semicircle. Okay, half of a circle is a semicircle. Okay, what does a semicircle measure in degrees? Yeah, it measures 180. It's half of a circle. What's a circle measure in degrees? 360. Okay, this is, semicircle is 180. It's half of a circle, whereas a full circle is 360 degrees. Okay, so from here all the way around, we end up with 360. Okay. We're studying central angles today. Just so you know, central angles are much better than western angles. I mean, Mr. Vogel went to Western Washington University. I went to Central Washington University. They're like rivals, like UW and Wazoo. I just like to point out every year that central angles are much better than western angles. I'll make sure I go and tell this class that later too, just so they know. But if you have a central angle, really what you have is you have an angle that originates from the center of the circle. Okay? So when I'm dealing with a central angle, it's something that originates from the center. If this will focus, that'll be helpful. Okay. So if I draw an angle that starts at the center and ends on the edges there, that is called a central angle right here. Bless you, squared. It's a second power down there. Okay? And a central angle has the same measure as its corresponding arc, which we'll talk about here in a minute. But if I label this, say, like A, B, D, to be more creative, okay? If we call that angle ABD, that central angle, if this measure right here was 60, then the measure of the central angle would be 60 degrees. If it was, say, 80, I'm going to make that an 80-degree central angle. The measure of angle, ABD, equals 80 degrees. Very tough to read that 80. Good thing I'm using a pencil. Trying to change my poor habits. So there we go. Okay, 80 degrees. All right, a minor arc. A minor arc is an arc that is less than 180 degrees. A minor arc is an arc less than 180 degrees. Okay. So for instance, if I put another point over here, let's call it point F. Well, the arc AD, and we call that arc AD like this. We put a little frowny face and call it arc AD. Arc AD is a minor arc. It's less than 180 degrees. It actually has the same measure as its central angle. So this arc measures the same as this angle. That arc is also 80 degrees. So central angles and their corresponding arcs have the same measure. This is a minor arc because it's less than 180. Now notice with a minor arc we only use 2 letters. A major arc is greater than 180. Okay? So if you're taking notes on this, and we'll use it later on, so a minor arc measures less than 180. Okay? A major arc is greater than or equal to 180. All right. So a major arc here, you use 2 or 3 letters for. So if I was naming arc, this arc right here, from A to D this way, we couldn't call it AD again because that implies a minor arc. That implies us going this direction. So we use 3 letters for it. So AFD. Arc AFD, the major arc AFD, has a measure of, anyone know? Yeah. Go ahead, Grace. Yeah. 80 degrees? That's not 80. Huh? 280? Did you say 280? Yeah, it's 280. Yeah, it's the way we figure it out, it's a circle, right? So we take 360 degrees, the whole circle, and we subtract out how much? That piece of the pie, 80 degrees. So that gives us a total of 280 degrees. Okay? Good. Is that what you said? Yeah. I thought you said 80. I'm sorry. Okay, arc AFD measures 280 degrees. Okay? All right, so we have everything except for adjacent arcs right now. We have minor arc measuring less than 180. Major arc is greater than or equal to 180, and adjacent arc. Adjacent arc is arcs that share a leg. So if I use the same picture and I draw in another line here, and Blake, what do we want to call this point? We can't call it B because we already have, Huh? E? All right, E. So if we want to go arc AE, so in this case adjacent arcs, we'd have arc AE, and tell your neighbor what an adjacent arc, a neighboring arc. Okay, volunteer? No one knows, so take a guess. Cameron? AD. AD is an adjacent arc. Can anyone find another set that are adjacent? So they neighbor, right? They share an angle there. They share a point. What'd you say? FE. Okay, so from here to here, that would be an adjacent arc. Yeah? EFD is adjacent to EA. Good. They share a point. Okay? They're neighboring arcs. All right. Any questions so far? Went through a bunch of definitions. Amazing fun. Okay. Tell your neighbor which definition you think is the coolest and why. We're going to talk about the arc addition postulate now. Here we go. Page 98 in your book talks about the arc addition postulate. I want you to read that postulate and then tell your neighbor in, like, teenager terms what it means. You don't really need a book. You just. Sorry, it's hard to see point C there. Okay, Julian's going to summarize it for us in teenage terms. Go ahead.
Arc plus arc equals bigger arc.
Okay, smaller arc plus smaller arc equals bigger arc. So this small arc plus this small arc equals this big arc. Amazing but true. Okay? That's really what it's saying there. That's arc addition. You add 2 things, you get the sum of the thing that they create, the bigger. Okay? It's like if you have one candy bar and you add to it another candy bar and you eat both of them, you eat the big long candy bar. Okay? That's really what you're doing. All right. That's arc addition postulate. All right. I want to go through and try some problems off our assignment. So this is the first one. I want you to read through it while I hand out your assignment. Tell your neighbor. You guys talk about how you're going to solve it. Okay? What tools you have in your bag to do that. Okay, can I have your attention back up here, please? Thank you. All right. What do we do? What are our thoughts? Bethany.
Well, to find the center, what I was thinking was that you find the distance between the two and then divide by 2.
Okay, so we could find the distance between these two and divide by 2. How many had something similar to that? Okay. How many said use the midpoint formula? Okay. Either way works. You can find the distance, use the distance formula and cut in half, or use the midpoint formula. If I use the midpoint formula, the midpoint, remember that in midpoint we just add our x values up and divide by 2. So it would be x1 plus x2 divided in half, and then y1 plus y2 divided in half. Okay, and that's a coordinate. In this case, if I call that x1 and y1 and x2 and y2, applying that midpoint formula again, we're going to have 1 or negative 1 plus 3 all cut in half. And then we're going to have 3 plus negative 1 all cut in half. And you'll notice I put them in parentheses. I try to keep that habit up. It won't really matter tons right on this problem, but that gives us 2 over 2 or 1 and 2 over 2 or 1. Or to pair 1, 1. Happens to be right there, and it appears as though that's right. Okay? Thank you. I know, I'm allergic to teenagers. Not you guys, other teenagers that were walking outside. Other questions? We'll do the distance formula here in a minute on another problem. That's why I didn't go through it on this one. Midpoint might be a little quicker, but either way works, so fine with either. Yeah? Roy?
Wait, so are we finding the distance of the radius?
Well, that was the first start, right? It says find the radius and the coordinates of the center. So we found the coordinates of the center. We haven't quite finished the problem with the radius. Yeah. Okay. So how do we find the radius once we know that this is 1, 1? That's kind of what Bethany was doing, right? Is that why that's why you use the distance formula? Okay. Now, if you want to use the distance formula from here to here, after you use the midpoint, you can do that. Okay, if you want to find the distance of this and then cut in half, you can do that. Go ahead and remind your neighbor what the distance is. How do you find the distance formula? Or use the distance formula? How many of you remembered the distance formula by heart? Hey, well done. All right, so if you want, you can use these. I'm going to go ahead and I'm going to change my values for x1 and y1. I'm going to call this now my x1 and y1 for the distance formula. I'm just going to go here. Okay, so rather than using this coordinate, since I just want the length of the radius, in this case, if I subtract the 2, x2, so 3 minus 1, minus x1, and squared, and y2, negative 1, and y1 is 1. Oops, forgot the negative. And we'll square it. We end up with, what do we get here? This is 2 squared, 4, and here? You get negative 2, right? When we square negative, what do you get? It's root 4, or root 4 plus 4 is root 8. Now remember, you've got to make sure that you do everything in the radical first. You can't just take the root of each of these. Okay? Root 8 becomes 2 root 2, right? Simplifying your radical. So for those of you who've forgotten that, just a quick review. Root 4 times root 2 makes root 8. This part becomes 2, so that's 2 root 2. Okay, so our radius is 2 root 2. The center of the circle is at 1, 1. All right. Bethany.
Did you already divide by 2?
I used this point. So since I had found the midpoint, I didn't need to divide by 2. But if you would have used both of these and the way you're talking, then you would have had to divide by 2 at the very end. Other questions? Okay. Very good. I want you guys to take a look at number 5 on the example side. Read through it. Discuss how you're going to solve it with your neighbor, and then give it a go. Example side. Hey, volunteer. Thoughts on it? Maddie.
So what you would do is you would times that 8.8% by 360, I think that's the whatever angles are these, and you would get 31.68, which is the angle.
Okay, good. So there's 360 degrees in a circle, right? And out of those 360 degrees, we want this percent of them, 8.8%. Okay, so you multiply 360 by 8.8%, which, by the way, is 360 times, you move that decimal over a couple, right? So that gives us 0.8 or 0.088, which would be, what'd you say, Maddie?
31.68.
31.68 degrees. It says round to the nearest degree, though, so we'll make that 32 degrees. All right. Was that what you're going to say, Julian? Go for it, Julian.
You take whatever the percentage is and then multiply 7.6.
What's that now?
You take whatever the percentage you start with is,
Uh-huh.
which is 8.8, and then you just multiply by 3.
Okay, so you're dividing this one by the 100 versus that one. So that works. Okay. Good. Both way gives you 32 degrees. Well done. Grace.
Well, I said that's like 100 over 8.8 is equal to 360 over x.
Good. So you used a proportion. Okay, so you said 360, or did you say 360 over x? Okay, so you said 360 degrees over x degrees is equal to, okay, over 8.8%. Okay, and you end up dropping or kind of going that route. Okay, so you set up a proportion. Either way, any of those ways work. Okay? All right. If you just multiply by the decimal form, that works. If you go this route, that works as well. Okay? Other questions? Good job. Hey, it's good discussion. Why don't you guys take a look at example 3. Let's talk about how we're going to do those problems. Discuss with your neighbor. 10.
If you know that DBE is 90 degrees and DBE is 20 degrees, you take 90 degrees minus 20 degrees.
Okay, so you know that this whole angle is 90. And you know that this part of it is 20, which makes this have to be 70, the complementary. Good. Who said complementary? Well done, yeah. So if that makes this arc, DB, also 20, which makes this arc the same as that central angle, which is also 70. Remember, the central angle and this are the same. So this is 70. Okay, this one's 20. Good. 70 degrees. Now, if we're going BDA, that's going this way, right? That's the big angle. 180 or greater. So this one just happens to be a 180. What do we call that?
Semicircle.
Yeah, it's a semicircle. Okay? It's also supplementary angles. Yeah. Semicircle there. Good. Any questions? All right. I've got 2 more problems I want to work through, and one will be hopefully pretty quick. If we look at 16, anyone tell me, or actually tell your neighbor what the relationship between these 2 angles are? Hey, volunteer. What do we know about those 2? Maggie? They're vertical angles, and vertical angles are? They're congruent. They're the same. So good job with the vocab. Vertical angles are congruent. So we don't want to forget about those. Now, that's not what it's asking here. It's asking for PQ. So you got to mind our P's and Q's here. Okay? This is 36 right here, what's the supplement of 36? Julian?
144.
Cameron, you second that? 144? Good. Yeah, no matter how you look at it, this way or this way, right here, they both have to make a straight line. Straight line adds up to 180, so this has to be 144 degrees because this angle, the central angle, is equal to that arc. Those are the same. Okay, our assignment is, yeah,
So back to the top one, well, both of them really.
right
You
here.
have- Yeah, on example 3.
Okay.
Like number 15 and number 13, if you have 3, does that mean like it goes the long way around the circle?
Correct. That means it's a major arc. It means it has to be 180 degrees or bigger. It goes the long way. Okay, your assignment is the mixed side all today. We're going to skip the rest of the example, not do any more of that. Let's go to the mixed side. I want to do the first problem together, which is actually number 15. So the first problem, which I'm calling the 15th problem. Okay? Okay, so take a look at the 15th problem. I want you to try it with your groupie. For this problem, again, we're once again looking at the radius of the coordinates of the center and for the radius of the circle. Endpoints are given. So if you want, once again, you could think, hey, this is a diameter. Okay? If I want the center is just the midpoint of that diameter somewhere. All right? So to find your midpoint, or your center in this case, use your midpoint formula. Your y or x2 plus x1 divided by 2, and your y2 plus y1 divided by 2. Now I heard a bunch of you talking about doing that. Some of you get confused if it's minus or plus, and that's okay. Just make sure you look it up when you're doing that. So I'm going to call those are my 1s, and these are my 2s up here. Doesn't matter which route you go. But I go here, I get -2 plus 6 over 2, or -4 over 2, which is -1. Is that right? No, -2. I only got -2 for the x value. No? Got it. Did I put the wrong one?
Well, it's -2 plus 6.
-2 plus 6 is 4. Oh, that's +2. Sorry. Is that better? Okay. Whew. That wasn't even on purpose. All right. Okay. Y2, I get 1. Y1, I get -5. -4 over 2, which is -2. Everyone get 2 -2?
Like in the exact
Okay.
order.
So if this is my midpoint at 2, -2, so maybe putting in the correct location there.
Yeah. Oh, I thought it-
Use the distance formula, right? From here to here. Find our distance. Okay, so distance is equal to the square root of, we call this our 1s now, x1 and y1. So I'm going to cross those out. I've got x1 and x2, so -2 plus 2, quantity squared, plus, excuse me, minus. Hi. I'll be right there. Okay. Y2 is, got 1 plus -2 squared. All right. So go ahead and finish that up. I'll open this up here. Oh. Grace, yeah. Yep. Okay? -2 plus 2? Uh-oh. What do we get there? Huh? 0? How many got 0 right there? Yeah, dude, what's 0 squared? 0. Huh?
There's not 2 2s.
Oh, yeah. What did I do wrong?
You added the midpoint.
Hey, what did I do wrong there? One person caught it. Did you catch it? Hey guys, remember when I walked around, I said that some of you are messing that piece up. Make sure if you're not getting these formulas down, that every time you rewrite them out. You should be subtracting in the distance formula. You're adding in the midpoint. Okay? Now, how many of you knew that? Okay, now one person said it. One person caught it. So you guys, I want you following along. Make sure we're catching it. So this actually is what? Negative 4 squared is? 16 plus 3 squared, or 9, gives us root 25, which is 5. Okay, so the radius is 5. All right, center is 2, negative 2. Okay. All right, I'll be walking around answering questions if you need help. My suggestion to you on these types of problems up here, if I were you, I would just go through the circle and try, before I even read the questions. So some of you are listening to it, before I even read the questions, I would just figure out what all these angles are before I even start it. Just based on what you know about circles and what they've given you. Just go through and write in all your angle measures. That makes those problems a lot easier. Okay, then go through and answer the questions.